In this lesson, you will learn how to add, subtract, multiply, and divide functions, and also you'll learn how to find the composition of functions. So to begin with, we're going to talk about the addition of functions, or the sum. So the sum of functions, we can say that f plus g of x equals f of x plus g of x. And we'll explain this more with examples in a little bit. Basically, you can separate into two parts where we have f of x plus g of x. And with this, the domain is going to be the intersection of the domain of the f function and the domain of the g function. And that's what we see here with this notation. It's the intersection of the two domains. Now for the difference of functions, we can say that f minus g of x equals f of x minus g of x. So again, we can separate into two parts. And the domain of this is going to be the intersection of the two domains of the two functions. For multiplication of two functions, again, we can take f times g of x and write it as f of x times g of x. And again, the domain is going to be the intersection of the functions of the domain of f and the domain of g. And then for dividing functions, if we have f divided by g of x, that is equal to f of x divided by g of x. And the domain of this is, again, the intersection of the two domains, the domain of the f function and the domain of the g function. But also take note that the denominator, whatever's down here, cannot equal 0. All right, so that's the domain of a quotient function. Now let's practice a little bit with these concepts. So here we have two functions. We have f of x equals 3x minus 1 and g of x equals x squared plus 3. And for our first example, we are trying to find f plus g of 2. And there's actually two ways you can go about doing this. All right, one way is we can keep it in general, where we have f plus g of x, and realize that to find that addition of the functions, we can separate as f of x plus g of x. Well, if you do that, you're just adding the two functions. So you're adding 3x minus 1 with x squared plus 3. So we write that out, 3x minus 1 plus x squared plus 3. And then combine like terms, negative 1 plus 3 would give you plus 2. So we can write this as x squared plus 3x plus 2. So now from here, we're trying to evaluate that function when we plug a 2 in for x. That's what that 2 means. So we can plug a 2 into this function now, where we have the x squared plus 3x plus 2. You plug a 2 in, we would have 2 squared plus 3 times 2 plus 2. 2 squared is 4, plus 3 times 2 is 6. 4 plus 6 is 10, plus 2 is 12. So f plus g of 2 would equal 12. The other way you can do this is right here, realizing that when you separate as f of x plus g of x, we could evaluate right there, because we're plugging a 2 in for x, we can write this as f of 2 plus g of 2. So if you wanted to, you could do it this way. Instead of combining the functions first before plugging in, we could evaluate each function individually. So you could do it that way. If you plug a 2 in for x in the f function, we have 3 times 2 minus 1, which is 5. Plug a 2 into the g function, we have 2 squared plus 3, that would be 7. And notice 5 plus 7 is equal to 12. So two ways to approach that. Either way, we're going to get 12 as our solution. Now let's try an example with subtraction. We have f minus g of 1. And again, two ways we can think of this. First way is we can keep it in general, where we have f minus g of x, and realize that is the same thing as f of x minus g of x. So you could take the time to write each function out, where we have 3x minus 1 minus the x squared plus 3. And we see that typed up right here. And then you subtract the x squared and the 3. So we have 3x, and then negative 1 minus 3 is negative 4. So 3x minus 4, and then minus the x squared. So now at this point, if we wanted, we could plug in the 1. So you plug a 1 in for x into this new function. So we have 3 times 1 minus 4 minus 1 squared. That is 3 minus 4, which is negative 1. And then minus 1 squared would be minus 1 again. So negative 1 minus 1, that gives you negative 2. So that's one way you can approach the problem. The other way is, if you look right here at f of x minus g of x, you could plug a 1 in right at that point, where we have f of 1 minus g of 1, and then do each part separately. So f of 1 would be 3 times 1 minus 1, which is 2. And then minus x squared plus 3, plug a 1 in for x. So we have 1 squared plus 3, that's 4. So 2 minus 4, that would give you negative 2. Notice that is the same thing as doing it this other way. So again, two ways we can approach this problem. Now before moving on to the multiplication and division, we also want to take into account the domain. So if you were asked what is the domain of f plus g of x, so the domain of f of x is all real numbers, because you could plug in any number for x, right? Domain means the possible values for x. You could plug in anything for x, that's fine. For g of x, same thing, you could plug in any number for x. So the domain would be all real numbers here. Now, the domain of the f plus g of x function, so if you add the functions together, the domain is the intersection of the two. Well, they're the exact same domain, so they're going to be the exact same domain as well when you add them. So the domain of f plus g of x would be all real numbers. All right, and same thing for the subtraction function, all right, because again, the domain of f of x is all real numbers, the domain of g of x is all real numbers. So if you intersect them, figure out what do they have in common, it's going to be all real numbers. So the domain down here as well would be all real numbers. Now let's talk about multiplication. Here we have the same two functions, and we're trying to find f times g of 1. So we could write this as f times g of x, and then figure out what you get when you multiply those functions together. And this is actually probably the longer way, but we'll show you this way and then the other shorter way. But what we can do is we can write this as f of x times g of x. That is the same thing. So we can take 3x minus 1, multiply that with x squared plus 3, and when you do that, we can FOIL. We get 3x cubed, and then 3x times 3 is 9x. Negative 1 times x squared is negative x squared, and then negative 1 times 3 is negative 3. All right, so you can distribute like that, and we're going to get this right here. And then once we have this, that's our f times g of x function, we can plug a 1 in for x. So what we're going to have is 3 times 1 cubed plus 9 times 1 minus 1 squared minus 3. So that'd be 3 times 1, that's 3, plus 9, that's 12, minus 1, that's 11. 11 minus 3 is 8. So your final answer would be 8. That is f of g of 1. The other way of approaching this is we could do right here at f of x times g of x, we can plug in the 1 right here to get f of 1 times g of 1. And f of 1, just plug a 1 in for x right there. 3 times 1 minus 1, that would be 2. And then g of 1, you plug a 1 in for x, we have 1 squared plus 3, that would be 4. And then 2 times 4 is 8. So either way, we get the same answer. You can use either approach when you multiply the functions. And then now the domain of the two functions. Again, we've already said the domain of f of x is all real numbers, the domain of g of x is all real numbers, and the domain of the product of the functions will be the intersection of the two domains, which would still be all real numbers. So the domain of this product of the functions is going to be all real numbers. One more example, we're going to work with f divided by g of 2. So this can be written as f of x divided by g of x. All right, because it's a division function, we can separate it. F of x is 3x minus 1, g of x is x squared plus 3. That doesn't simplify at all, so you can just leave it like that right there. Then you plug a 2 in for x, we would have 3 times 2 minus 1 over 2 squared plus 3. That gives you 5 on the top, 7 on the bottom. So your function, when you divide the two functions, would be 5/7. And the domain for this one, again, it can be all real numbers for f of x, all real numbers for g of x. Where do they intersect? Well, it's going to be all real numbers. Now, the other thing to take into account is the denominator. So x squared plus 3, the denominator, cannot equal 0. So if you solve this for x, we're going to get x squared cannot equal negative 3. Take the square root of both sides, and that's going to be imaginary. So in this case, we're not limited at all by the denominator. There's times, though, if it was x squared minus 3, not equal to 0, this would be a positive 3 on the other side, so x would not be equal to the square root of positive 3, and that would be a limitation. All right, so take that into account when you're finding the domain of the quotient of two functions. Now on this slide, we see what is called the difference quotient. And this looks maybe kind of weird and maybe a little abstract as well. But we're showing this because this is used in calculus. So we need to know this eventually if you're going on to calculus. So we're introducing you now to this concept. So this is our difference quotient where we have f of x plus h minus f of x over h. And now how this works is, let's say we were trying to find the difference quotient of f of x equals x squared minus 2. So what we do is we take that difference quotient right here, we take this, and in place of f of x, we can put in x squared minus 2. All right, so that would be x squared minus 2 over on that side. And then h is going to go on the bottom. The weird thing is going to be right here. Okay, this is usually the trickiest part. What we're doing is, in place of x, we're plugging in x plus h. So instead of x squared, we have x plus h squared. And then minus 2. All right, so this would be what we have. And now from here, we just want to simplify this expression. So we see typed up what we had written. So we have this expression, and then let's try to simplify a little bit. So here we have x plus h squared. So you square the first term to get x squared. You multiply and double x times h times 2. That gives you 2xh. And then you square the last term to get h squared. Then you have minus 2, and then minus. So you have minus the x squared, and minus negative 2, which becomes a plus 2. And the bottom, you have h. All right, so from here, notice we have x squared minus x squared. That would cancel out. We have negative 2 plus 2. That would cancel out. What you're left with is 2xh plus h squared divided by h. Now from here, we can divide everything by h. What you're going to have now is 2x plus h over 1, or simply 2x plus h. All right, so this would be the difference quotient of f of x equals x squared minus 2. And basically what we found is what we call the derivative of this function. And again, if you take calculus, that is where you'll learn about this in more detail. Now, one more thing with functions is what we call the composition of functions. The composition of functions is denoted by this expression right here. So with like a raised little circle in between the f and the g. And this is a function whose value at x is given by f of g of x, and is equal to this right here. All right, so how this works is, for example, if we had two functions, f of x and g of x, and let's say we're trying to find f of g of x. All right, so the composition of f and g. All right, so this notation here is actually simpler if you think of this as f of g of x, and you write it out like this. It's the same thing, but it's simpler if you write it out like this. And then from here, what we're doing is we're replacing the g of x in this notation. We replace that with the 2x minus 1. That's the same thing, right? So we can replace the g of x with 2x minus 1. So now we have f of 2x minus 1. Now from here, what we do is we will take the 2x minus 1 and plug it in place of x into the f function, right? Because f of 2x minus 1, you plug it into the f function. So now instead of x squared, we have 2x minus 1 squared. And then instead of plus 2x, we have plus 2 times 2x minus 1. All right, so now from here we can simplify. 2x minus 1 squared would be 4x squared minus 4x plus 1. And then here we can distribute. We have plus 4x minus 2. And then we can simplify. These will cancel. We have 4x squared, and then 1 minus 2 is going to be negative 1. So your answer is f of g of x equals 4x squared minus 1. Let's try another example, and you can see if you can do this one on your own. Here we have g of f of x. So we're switching the order. All right, so what we're going to do here is we're going to have g of f of x. It's probably easier if you write it out like this. And then what we're doing is we're replacing f of x with the f of x function, which is x squared plus 2x. So now we have g of x squared plus 2x. Now from here, what we can do is we can replace x in the g function with x squared plus 2x. So instead of 2x minus 1, we have 2 times x squared plus 2x minus 1. And then from here, we can distribute. We get 2x squared, and then plus 4x, and then we have the minus 1 at the end. So your answer is going to be 2x squared plus 4x minus 1. Now the question always is, how can we apply these different things to actual problems? So here we have an application of composition of functions. Here we're told that the weekly cost of producing x units in a manufacturing process is given by the function c of x equals 60x plus 750. The number of units produced in t hours is given by x of t equals 50t. Find the time that must elapse for the cost to increase to $15,000. So notice we have a cost function, then we have a function here dealing with time. And what we're being asked is to find the time that must elapse for the cost to increase to $15,000. So notice we need to somehow relate cost and time together. So what we can do is we can merge the two functions by doing a composition of functions to determine an equation or a function that we can use to solve this problem. So what we're doing is we're going to do c of x of t. So we're combining the c of x function and the x of t function. So when you do this, you can replace x of t with 50t. So now we have c of 50t. And what we do now is we plug in 50t in place of x into the c function. So now we have 60 times 50t plus 750. So that would give you 3000t plus 750. And we can set this equal to $15,000. And the reason is because we wanted this cost right here, c of x of t, this cost function merged with the x of t function, we wanted that equal to 15,000. So we set this equal to 15,000, and we see that typed up over here, and then solve this for t. So we subtract 750 to bring it over to the right side. We now have 3000t equals 14,250. And then to solve for t, we can divide both sides by 3,000. So when you do that, we're going to get t equals 4.75. So t is given up here to be in hours. So our answer is that it's going to take 4.75 hours, or 4 hours and 75 minutes, for the cost to increase to $15,000. And that concludes our lesson for today. We will see you next time.